Hello everyone, hi, this is Fahad from Future Phones, and today we have a MacBook Air to repair. This MacBook Air has some intermittent issues, so sometime it will charge and sometime it won't charge, and sometime it will stay with the battery and sometime it will not. So let's say if let's say this is on right now, yeah, and we have it connected, the battery is connected, and we have the DCIN connected also. So if I remove the battery, it was previously doing, when I remove the battery, remove the DCIN connector, it would if you it would turn off even the battery is connected. Battery is 100% charged. You can see in there, just 1 minute, I'll show you in there. You can see the battery is 100% charged, yeah, and battery is charged. The customer bought a brand new battery because he thought that the battery was faulty, and that's why he bought a new battery. And let's see, if I remove this DC in connector, if it powers off, then we still have the same problem. Okay, there you go, it powered off. DC in connection removed and it powered off, even though the battery was fully charged. Now there is a few things that we can look at why we are having this issue. We will go through the diagnostic and what is the logic behind those steps that we will take, because we just don't want to test parts and check, but we want to see what the schematic says and how the schematic works, and what sort of a basic logic is behind this battery keeping the laptop on. So if you know what I mean, you know, like what we are having problem right now, the battery cannot keep this laptop on. You can see, yeah, you can see the DC in connection also is coming on and off. The fan is spinning, so it's just powered off now. So let's see. Before we do anything, I want to remove this battery connector and remove this battery. We know that this is a good battery because I have my own original battery, and we tested with this battery and we were having the same result. This is an original Apple battery and we had the same problem with this battery. Now I will remove this LCD connector. I don't know why this zoom is just playing about. Okay, and I will remove this connector, keyboard connector. I'm sorry, I don't know why this is not setting up properly. Just give me a second. I think this is better now. So I've just removed the LCD connector. I'll remove this hard drive also, SSD card, and is there any more? Yes, I have a speaker connector here. I'll remove that also. So intermittent charging, sometimes it's charging, sometimes it's not, and if you remove the DC power, if you remove the charging jack, it would power off, so it's not staying on with the battery. So this is our board, and we know that the customer has already changed the battery, and this is not in a very good condition, as I see in the microscope. It's liquid damage all around, and let me just focus it. Yeah, so the part number for this is A1465. this is the model number, and we have the board number also. Let's see what is the board number for this. I think we have a board number here, which is 820-3208A, So this is the board number, and so I mean, with the very initial powers that we receive from a MacBook with the DCIN section is the 3.42 volt, and then PP bus G3 hot, which is like a 8.6 volt. So we will test them. Our multimeter is on. So our multimeter is on, and we will test 3.42 volt, which is available on this coil here. So you can see the state of this area, which is like corrosion and all that. So we have 3.42 volt available here, and since this laptop is powering on, so we should also have 8.6 available. So we will see where the 8.6 is. So we don't have 8.6 here. Where is the 8.6 coil? Just give me a second. Yep. So this is about 8.6. We have 8.6 available also on this coil. So we have 8.6, we have 3.42 available. Okay, I want to test now with my battery. So these are the two main voltages that will support the laptop to power on, 3.42 and 8.6. If they are available, then the laptop or the MacBook will power on. So let's see. If I just connect this, and what situation we have. Do we still have 3.42 on the coil? So remember, before we checked without battery. So we have 3.42. That's good. Do we have 8.6 volt? Yes. Okay, but it's not 8. This, you can see, it's not 8.6. It's 8.059. So something is not right, probably. Just check here. What? Okay, it turned off for some reason. I think it's resetting itself. 7.92. Okay. 8.01. So something is not right. Okay, if I remove the DCIN connector now, so do I receive 3.42 volt? So you see that we have a 1.7. So we are not getting 3.42 volt. 3.42 volt is the first voltage that we received, and that 3.42 volt will help us make 8.6 volt, and then 3 volt and 5 volt. So the first voltage is 3.42. so we have to work on the 3.42. we need to get 3.42 in condition when the battery is connected. You can see the battery is connected, so we should receive 3.42 volt here. Okay, well, we are not receiving this. Okay, let's open the schematics, and let's go through the schematics for a while, and we'll see what we are talking about here. Okay, so this is our schematics. Just arrange it. Oops. So we were looking for 3.42 volt. Why I'm saying that, you will know in a minute. .42. So this is a PP3V42 G3 hot. Okay, let's just select it. I don't know where it is, but we are interested in 3.42 volt. So yes, it came into the right place, and you know this is the coil we were testing. I'm just going to check this. So this is the 3.42 volt, And when we checked before, we checked it with the DCIN cable connected, so the power was coming here, which was 18.5 volt. In our case it was 16.50. so this voltage was coming here and it was going through this resistor R6905 and through a diode, and then we were receiving here. Where is it gone now? Just 1 minute. It's a bit slow. I think I'm using too many things. Let me just get rid of that. It's still slow. Why is it slow? Okay, so this is our coil L6995, and this is where we are supposed to receive 3.42 volt. Okay, the condition is, in this circuit we have two inputs. We have one input from the DCIN section, which is here. DCIN section will provide 18.5 volts, and they will go through this diode here. You can see this diode here. So it will go through this resistor and then this diode, and is a double diode actually. So yeah, right, and then it will go past this U6990. So it will step down 18.5 volt into 3.42 volt, and this is our first voltage to make the board running. So this is the very first voltage we need to get the board going. So in our condition, DCIN section was providing all this voltage here through this diode, and it was using this IC, and we were receiving 3.42, which we seen before. Okay, the other input is the PP bus G3 hot, and this input is through the battery. So when we connect the battery, so PP bus G3 hot becomes alive, and there is voltage available through the battery. PP bus G3 hot is a 8.6 voltage is available here. So PP bus G3 hot will come from the battery to this resistor R6920 on pin number 1 here, and then it will go to pin number 2, and then it will go through this diode. Okay, and then it will go through this IC U6990, and then we will have through this coil 3.42 volt again. So in condition where the DCIN jack is connected, so we will receive voltage through this line here, and it will go through here. This is when the DCIN jack is connected. If it's not connected, then the voltage will come through this PP bus G3 hot. PP bus G3 hot will provide 8.6 volts, and it will go through this circuit, and we will receive 3.42. So in our case, this is not happening. When we connect the battery, we are not receiving 3.42 volt here. So this is the very first voltage that we are going to look at, and we will see why we are not receiving 3.42 volt through this IC. And our input, the first step of our input is this resistor R6920. So this is the first component where the PP bus G3 hot will be available. So we will go back to this microscope now, and we will see what is happening here. We'll remove this battery. We'll remove the battery because we don't need it, and we will check where it is. So if I go back to my desktop, and we will see where is this R6920 located. So R6920 is here on the other side. Okay, so microscope, and I will turn the board around because it's in this section. Okay, so you can see what happened here. This is your R690. possibly. Let me just check. R6920. So this is the R6920. So you can see we have two resistors here. One is 10 kilo ohm resistor and the other one is 4.7 kilo ohm resistor. So I think it's a 10 ohm resistor, not kilo ohm, sorry. Yeah, it's a 10 ohm resistor and the other one is 4.7 ohm resistor. And you can see how it looks. The resistor looks in a bad condition. I think this resistor is blown. So that's why our DCIN section is working. So your DCIN section is the power jack is coming through here from this point, possibly. Let's see, is it a pin number 1 or 2? We just check. So pin number 1 is R6910. Yes, that's right. So this is the pin number 1. This is where we will receive the voltage from the DCIN, and on this resistor at this point on this side we will receive the power PP bus G3 hot from the battery. So we will take the measurement of these two resistors and let's see. I'm quite sure we have a problem with this one because it's blown, but we still get some measurement. Sorry, it's the okay, resistance mode, and we get the 10 ohm. So this is a 10 ohm resistor and this was supposed to be 4.7 ohm resistor. Okay, you can see is the value is increased to in kilo ohms because this resistor has its time now, is blown, and is supposed to be a 4.7 ohm resistance here, but it's coming up with 224 kilo ohm. So this is a lot, and we will replace this part, and after that we will see what happens. Okay, so my hot air station is on now, and I have found a donor board. So I will take the part from this donor board and we will use in our board. Okay, I'll just take it. A little longer and use some flux. Okay, I'll increase the value to max for this hot air station. Okay, here it is. Struggling with this bloody resistor. Come on. Yes, so this is our replacement resistor from the donor board, and let's keep it nearby. It's a 4.7 ohm resistor. So we have, sorry, I think you missed all the action. Okay, so the replacement resistor in place now. Let's give it a clean, and so our testing criteria is, again, we will connect the battery and we will see if we receive 3.42 volt. We can check this resistor also if it's giving the right value. Let's see, we are in the resistance mode now, and check it. So it's a 4.7, which is okay. And now we will connect the battery, and if that resistor was the problem, then we should receive 3.42 volt at that coil. Let's check. Yes. See, we got 3.42 volt on the coil. So I think it's fixed. Let's give it a test. I'll connect it to the board, and I can do one more thing. What it was doing before, it was as soon as I removed the DCIN or the charging jack, it was powering off, and if everything has gone right, then it should not power off, and it should keep running on the battery also. So let's check it. I've got it connected. Use this camera now. So I will connect power. I'll let it power on. So you can see it's powering on. DC in connection. Charging power is also connected, the battery is connected. So simple test is, if I remove it and if it does not power off, then our problem is resolved. So let's see, 1 2 3 go, bingo. So you see it's powered on. It's giving me a folder sign because the SSD is not connected, and it's keeping it on. The battery is keeping the laptop on. So I hope you have learned the logic behind what happens when you connect the battery to the MacBook, and how the power goes through that 3.42 volt. So basically PP bus G3 hot can either come from the DC in section, which is this one, or through the battery. So if the very first resistor is faulty for DC in, then this won't work. If the first resistor was broken for the battery, then the battery won't work. So it won't generate that 3.42 volt, and if it does not generate 3.42 volt, it will not create the 8.6 volt which is necessary to power on the laptop or keep the laptop on and running. So this is for today, and I hope you must have learned something from this video. Do like and subscribe to the channel. We will be adding more videos because there is so many channels and there is so much going on YouTube. If you do not subscribe to the channel, then we will be lost and you won't be able to find us again, maybe or maybe not. So it's best to subscribe so you can keep yourself updated with these sort of repairs. And I mean, how we want is we want to give them complete knowledge. The whatever we have, I want to transfer, and I don't want to hide anything. That's the main thing. And if you stay with us, then you will learn the logic behind the repairs that we are doing. Thank you for watching. Thanks a lot, and do subscribe and like our channel, and leave any comments if you have any questions to ask. Thank you very much. Bye bye.